Let's continue talking about solving algebra problems today. Today we're going to focus on separated variables in our problems. Now so far we've learned how to solve two-step algebra equations like this. 3x plus 9 equals 54. You should already know how to solve this. We talked about taking care of the addition first by doing the opposite operation or the inverse. That would be subtraction. So rather than adding 9, you're going to subtract 9. And remember to do the same thing to each side. I'll have 0 here, and I'll have 54 minus 9 would be 45 on the right side of the equal sign. Now don't forget that you still have 3x on the left side of the equal sign. And now your problem is 3x equals 45. We're back to a one-step algebra problem. This is multiplication when you have the 3 squished right next to the variable like that. So the inverse of multiplication then would be division. You're going to divide both sides by what number? Well, it could be 3 or it could be 45. Those are the only numbers that I have. You're going to divide by the 3 because the 3 is what is being multiplied. Divide both sides by 3. And we did that for a reason. That allows the 3 over 3 to just cancel right out. 3 over 3 is 1, and I don't even really have to show that. So then on the left side, I'm left with just an x. 1x, really. And 45 divided by 3, 15. So x equals 15. You had to do 2 steps to get x by itself. First, you had to subtract the 9, and then you had to divide the 3. Today, we're going to look at how to solve two-step algebra problems with separated variables. So look at this example and find both of the variable terms. 2x plus 3x equals 25. Aha, that should look a little bit different to you. What are the variable terms? Well, a variable is an unknown, which is usually represented by x, y, even z, n, anything like that. So I have one unknown term here, 2x, and I have another here, 3x. Now you can follow these steps to learn how to solve algebra problems when your variables are separated like this. Step number 1, combine the variables first. To combine variables that have the same letter, like x in this case, you will add or subtract the coefficients. Now we haven't talked much in this class about coefficients, but I'm sure you have in other classes. A coefficient, and I've highlighted it here for you, is a large number right in front of the variable. In this case it's a 2, in this case it's a 3. So I've got a positive 2 here and a positive 3 here, so add them. 2x's plus 3x's would be 5x's. So now in our original problem, rather than having 2x plus 3x equals 25, these will combine and become 5x. Here it is, 5x equals 25. That's back to a one-step algebra problem. Divide each side then by 5. So my 5 over 5 becomes 1. And I'm still left with x on the left. 25 divided by 5 becomes 5. X equals 5. So not too difficult as long as you follow these steps. All right, page 2. I'd like you to try a couple of these examples now. You can pause the video if you'd like, or just go along with us. 2x plus 4x equals 24. I need to add these. This is positive and this is positive. 2x plus 4x would be 6x on the left. And keep the 24 on the right. That was the first step. The second step says solve just like a one-step algebra problem. This is multiplication, so do the opposite. Divide each side by 6. 6 over 6 cancels. I'm left with an x on the left, and 24 divided by 6 is 4. Next problem. 9x minus 2x equals 14. Okay, so there's one difference here, and that's that you have a subtraction sign. That's going to have to go along with your 2. So when you're working these problems, make sure if you find your coefficient that you also notice if there's going to be a negative next to it. So 9x's minus 2x's. 9 minus 2 is 7. 7x's on the left equals 14. This is a multiplication problem, so do the opposite. Divide both sides by 7. Your 7 over 7 will cancel out and become a 1. On the left, you're left with an x. On the right, you've got 14 divided by 7, which is 2. All right, let's look at the next one. 10x minus x equals 63. Maybe you're asking yourself, well, okay, I noticed the negative here, but I don't see a coefficient in front of my x. Some of you might already know this, but I have a hint here for you just in case. If there isn't a number in front of a variable, assume the coefficient is 1. Sometimes if you're not sure, you can always just write it in. So 10x minus 1x. Combine those together. 10 minus 1, 9x on the left equals 63. Now we're back to a one-step algebra problem. Divide both sides by the number that's next to my x, which is a 9. 9 over 9 cancels. On the left, I'm left with x equals 63 divided by 9, 7. So those weren't too difficult, but there is a little twist, of course. Sometimes the variable will be on both sides of an equation like this. That's a little bit different. Now you see an x term on the left of the equal sign, and you see an x term on the right of the equal sign, and then you have your constant. So up above, you were working with everything on the left. So this makes it a little bit more challenging, but it's workable. You will just need to get the variables on the same side. Follow these simple steps. Number 1, move the variables to the same side using opposite operations. So maybe you're asking, well, do I move my 4 to the right on that side, or do I move my 2 to the left on this side? Usually I try to move my x term or my variable over to the left. That works most of the time. And in this case, that would work great because I'd have my x's on the left and I have just my constant or my whole number here on the right. So let's move our 2x over to the left of the equal sign. How do we do that? Opposite operation. This is a positive 2x here. You can add a negative 2x, so you're subtracting 2x from each side. And I've shown you how to do that here. Minus 2x on the right, minus 2x on the left. That lets these cancel. 2x minus 2x then would just be a 0. And on the right, I've still got my plus 8. On the left, 4x minus 2x. This is where you're combining your terms. That leaves me with 2x. All right, so we're not quite done. Then you're going to solve according to the rules for one-step algebra problems. You've got 2x on the left, and over here you have just 0 plus 8, which is 8. 2x equals 8 should be easy for you to solve at this point. This is multiplication, 2 times x. Do the opposite or the inverse, and divide each side by 2. 2 over 2 cancels. Oops. I don't know if you can see all that. There we go. 2 over 2 cancels, it becomes 1, and 8 divided by 2 becomes 4. All right, on the next page, I've got some practice for you again. Again, you can either just go along with us or pause the video here and work them yourself. So try these. 9x equals 5x plus 36. This is similar to the problem that we just did. You'll notice you have 2 x terms. You've got a term on the left and a term on the right. It makes the most sense to bring your 5x term over to the left because you'll still have your 36 here on the right. So subtract 5x from each side to get rid of that one. That's how you move it. Why did I subtract 5? Because I had positive 5 right above it. I just did the opposite. These then will cancel. That's just going to be a 0. On the left of my equal sign, I'll have 9x minus 5x, which is 4x. On the right of my equal sign, I've just got 36. Back to an easy one-step problem. 4x equals 36. So this is multiplication. What's the inverse of multiplication? Division. Divide both sides by the number right next to the x, by 4. That lets me say 4 over 4 is 1. Now I can ignore those numbers, and I've got x equals 36 divided by 4, 9. All right, the next problem, a little bit different. You notice we have two x terms. This one, 12x, and this one, 15x. This question here is a little bit trickier, and you should notice that there is more than one way that you could solve this. You could say, well, we've been moving our x terms left, let me do that. And you can do that. It's going to make your problem more than 2 steps, though, in this case, because you've got your 30 on your left. So to save myself some trouble, I think I just want to move my 12x over here to the right. That way I'll have my constant on the left and my x's on the right. I'm going to move it this way. So then I'm going to subtract 12x from each side. And then I can cancel these out. Plus 12x and minus 12x would just be 0. On the left of the equal sign, I've just got 30 equals 15 minus 12, 3x. And I'm down to a one-step problem here. It's okay that they're a little bit different than you're used to seeing them. It means the same thing. 30 equals 3x means the same thing as 3x equals 30. This is one of the laws of algebra that we don't talk about too much. It's sort of implied that you're able to just flip-flop everything on the left of the equal sign with everything on the right. Anyway, let's work with what we had initially. 3 times x is multiplication. Divide each side then by 3. 3 over 3 is 1. That leaves me with x on the right. And 30 divided by 3 is 10. 10 equals x. Now let me just go ahead and prove that it was the same thing. Remember how we just flip-flopped what was on the left and the right over here? As long as you take everything on the left and everything on the right, you can do that. Then I would divide by 3 on each side. I'm left with x equals 10. So 10 equals x is the same thing as x equals 10. All right, now I have 9v equals 33 minus 2v. Now, it's okay to have a different variable. We don't work with v's very much, but I wanted to throw one in just so you got some experience with that. I have a v term on the left and a v term on the right. My constant is here on the right, so it makes more sense for me to leave that 33 over here and move my 2v over to the left. That way I'll have my v's on the left. I have a negative 2v. Don't forget to look at that. In fact, I'm going to highlight that. That negative sign goes with my coefficient there. So the opposite then of subtracting 2 is adding 2. Always do the opposite. Make sure you do it to both sides. So negative 2v and plus 2v are going to cancel. On the right, I've only got 33. No variable terms. On the left, I have 9v minus 2v, which is 7v. Oops, sorry. 9 plus 2, which would be 11. I knew that didn't look right. Always check yourself, right? So this is multiplication. Do the same thing and then just divide 11 on both sides. V equals 11 over 11 is 1, so I can ignore that. 33 divided by 11 is 3. Last problem. 8x equals negative x plus 27. And again, just to make sure that I don't mess up, which I almost did, I'm going to highlight that negative. And if there's no coefficient, remember, it's just a 1. This is just a 1 right in there. a negative 1. In this case, I have my constant here on the right, so I think it makes sense to move this x over to the left. And how do I do that? You can't subtract x because that wouldn't be doing the opposite. The opposite of subtracting x or having a negative x is to add x or have a positive x on each side. That allows this to cancel with this. So on the right of the equal sign, I just have my 27, and I have 8x plus 1x, which would be 9x. This is multiplication, so do the opposite and divide both sides by 9. 9 over 9 cancels, and I'm left with x equals 27 divided by 9, which is 3. Very good.